Hi, and welcome to the Unit 2.1 CP Chemistry Notes video. This unit is called Properties of Matter. And in this video, I'm going to introduce the unit. The goal of this unit is to design and conduct an experiment to identify unknown substance by testing the properties of that substance. So that's a lot of words. Essentially what you'll be given by the end of the unit is an unknown substance. You don't know what's in it. And then you're going to perform a bunch of tests to identify the substance. The objective of this video is to define matter and talk about the properties of matter and how to test for these properties. And all of these objectives will help you prepare for that end of the unit performance task. All right, let's start off with what is matter. You've probably heard about matter before. Matter is anything that has mass and volume. So if it's something that you can weigh, that means it has mass. So if you can weigh it, or if you can measure its volume, then it is matter. You may also know that matter has a relationship to atoms. This is probably something you've heard about in middle school. So what is that relationship? All matter is made of atoms, and atoms are the fundamental building blocks of matter. So if you were to break down matter, if you break it apart, in the end, you would get a bunch of atoms. So you can think of matter, in addition to think of it as something that you can weigh or something that has volume, is anything that's made of atoms. All right, we're going to look at some examples and non-examples of matter just to clarify and make sure we know what matter is. So let's look at our first example. A lamp is matter. So if you can weigh a lamp, you can also measure the volume of a lamp, and the lamp is made of atoms. So the metal part, for example, is made of metal atoms. There may be some plastic bits right here that are made of carbons and hydrogens. So these are atoms that make up this lamp. A non-example would be the light from the lamp. You cannot weigh light. You cannot take the volume, measure the volume of light, and light is not made up of atoms. All right, let's look at another example, the air in a balloon. So even though air may be light, you can actually still weigh it. Air does have mass, and you can measure the volume of air. So it has mass, you can measure its volume, and air is made up of a bunch of molecules and atoms. For example, the oxygen we breathe, that is the molecule O2. That's something that we breathe in. That's a part of air. So is nitrogen. So is CO2. So a bunch of atoms are in air. A non-example would be wind, and this may be a bit tricky, but wind is the movement of air. It's not air itself. It's just the act of it moving. So wind is not an example of matter. All right, now it's your turn. You're going to try the CFU. What is an example and non-example of matter? Is it the heat from or the wood on the campfire? So which one is matter, heat or wood, and which one's not matter? And then make sure you explain by listing whether you can weigh it, can you measure its volume, and if it's made of atoms. Pause the video now, and after you try it, the answer will be revealed. All right, so wood is an example of matter. You can weigh wood, you can measure its volume, and wood is made of atoms. It's usually made of carbon and hydrogen atoms, and then there's usually some other types too. The non-example would be the heat. Heat is just energy. You cannot weigh heat, you cannot measure the volume of heat, and it's not made of atoms. It's just energy. Okay, so now that we talked about matter, this unit is about the properties of matter. So we need to understand what are properties in chemistry. And a property in general is a characteristic belonging to a substance. And when I say substance, I just mean a sample of matter. So whether it's a desk, a piece of paper, yourself, you would be considered a sample of matter, or a bottle of a chemical would be a sample of matter, like a bottle of potassium chloride would be a sample of matter. There are two types of properties. And remember, properties are characteristic belonging to that substance. There are two types of properties that we look at. Physical properties, those are things that you can just observe. So whether you observe by sight, smell, touch. We don't do taste in chemistry lab, but that's another way that you can observe something. So whether you observe things with your five senses, you can observe it without changing it, then it's a physical property. If you have to change it in order to observe it, then it's a chemical property. We are going to focus mainly on physical properties for this unit, but just know that there are two types. The physical properties we're going to be looking at are these that are listed here. And so for the next half, what we're going to do is we're going to go through the properties and ways of testing these properties. We're going to start with color. So color basically describes what it looks like in a way. It's a hue or what it looks like. So, and we kind of know like, oh, is it red? Is it blue? Is it green? And the way that we test it, we simply just look at it. So we use our sight as a sense to just look at it and see the color. For phases, when we say phase, we're talking about solid, liquid, or gas. And again, we can just look at something and tell whether it's a solid, a liquid, or gas. So for example, if you have a cup of water, the water is a liquid, and you can just tell it's liquid. It flows, etc. But the cup that it's in is a solid, and you can tell that it's a solid, right? So before we move on, I just want to quickly note some characteristics of the three phases, solid, liquid, and gases. Solids, we know that things are solid because they're sort of non-compressible, meaning you can't press them down and make them smaller. All right. Also, the volume of a solid and its shape is fixed. So for example, here you have a cylindrical container, and if you take a wooden block, let's say this is a wooden block, and you place it inside the container, the shape of the block is still a cubic shape. It doesn't change to fit the container. And also the volume doesn't change. It doesn't change to fit the volume of the container. Moving on to liquids. Liquids are also not compressible, meaning that you can't compress them down, squeeze them down. And the volume is also fixed. So if this container, the cylindrical container, was a 5-liter container, and we poured in 1 liter of liquid into the container, we would still have just 1 liter of liquid. The liquid won't fill up the entire container because the container is 5 liters and liquid is only 1. The shape, however, is not fixed. So you'll notice that liquids will flow in order to fit the shape of the container. So here the liquid is flowing towards the edges, and at the bottom here it has this sort of cylindrical shape to match the shape of the container. Gases are our last phase, and they are compressible, meaning that you can press or squeeze a gas down. The volume and the shape are both not fixed. So if you put gas in a cylindrical container like this, the shape of the gas is going to be cylindrical because the gases are going to spread out to fit the shape of the container. The volume of the gas is also not fixed. So let's say, for example, you had 1 liter of gas and you put it into a 5-liter container. The gas is no longer 1 liter. The volume of that gas becomes 5 liter because the gases will spread out throughout the container. And so now the volume of the gas is whatever the volume of the container is. So when we say not fixed, we mean that it's going to take on the shape and the volume of the container it's in. Okay, now that we've taken a pause and to look at some characteristics, let's move on to more properties. The next property we're going to look at is melting point. Melting point is the temperature at which something melts. So for example, if you have a block of ice and you let it melt and then you recorded the temperature at which it's melting, and we say melting, we mean going from a solid to a liquid. That temperature at which it melts going from a solid to a liquid is the melting point. Now, the way that we test it is we use what's called a melting point apparatus, and I'll show you what that looks like in a moment. So here's your melting point apparatus. It kind of got cut off at the top, but at the very top here, if you can see this thing that's sticking out there, that is a thermometer, and you use that to read the temperature at which your substance melt. Here is a viewing window. Inside that window, when you look inside, there'll be your sample will be in a small it's called a capillary tube. It's just a small little tubular container, and on the sides of that container are pieces of metal that will heat up the capillary tube. And so what will happen is it heats it up, and then the solid will start to melt into a liquid. And when that happens, you can record the temperature on the thermometer at which it's melting. And so here you're just looking, you use this to view your sample to know when it melts. And then finally, there's a temperature dial, which you can turn up or turn down the heat. Okay, so to really see it happen, there is a video that is embedded in this assignment. You're going to watch this video, and you're going to see how this person prepares the sample by packing it into the capillary tube, and then also how this person measures the melting point using the melting point apparatus. So when you finish watching this video, we'll resume with the rest of the properties. Okay, before we go on to the rest of the properties, I just want to make a quick note about melting point and and I'm using this abbreviation MP, of phases. So under ambient, which means normal conditions, like if you walk into a room, that's ambient conditions. If you walk into a freezer, that's not normal. We don't live in freezers, so that would not be ambient conditions. But ambient just means normal conditions, like of a normal room. So under normal conditions, we'll say, solids usually have a higher melting point than liquids, which have a higher melting point than gases. And I'm illustrating that here. Here we have sodium chloride, which is table salt, and we know that that's a solid. Look at its melting point. It's 108 degrees Celsius. The next thing over we have is water. Its melting point temperature is sorry, I had to change that for a moment. So for water, its melting point temperature is actually 0 degrees Celsius. So I just made that change. And then for, this is a helium balloon, so a balloon filled with helium gas. Its melting point temperature is negative 272.2 degrees Celsius. So basically what that's saying is that melting points of solids are going to be the highest, and the melting points of gases are usually the lowest under normal conditions. Okay, finally, let's move on to shiny and dull. So shiny means it reflects light, and dull means it does not. So this sample of matter is shiny. This substance, on the other hand, is not. It's dull. It does not reflect light, and we simply test it by looking at it. And I'm sure you know some things that are shiny, like a lot of times metals are shiny. Let's move on to the next property, malleable and brittle. So malleable means it bends or it dents when you hit it or drop it, and brittle means it breaks when you hit it. And the way that we test that is we will hit it or drop it, and that's called an impact test. So let's say we take a hammer and we hit these two substances with the hammer, what would happen? So the first substance, the shiny substance, it will dent, and then the dull yellow substance will break apart into pieces. And so the shiny substance is malleable because it will bend or dent, and then the yellow substance is brittle because it breaks. Okay, soluble and insoluble. Soluble means it dissolves in water, and insoluble means it does not dissolve in water. And the way that we test it is we would mix something with water, and let's say it was a juice mix, like orange Kool-Aid, and let's say this is sand. We mix it with water and we observe what happens. So you see with the orange Kool-Aid, it dissolves because it all looks like one thing and mixes well, and then with the sand, it doesn't. So the way we test for soluble or insoluble is we mix it with water and observe. So we would say the juice mix is soluble because it dissolves in water, and then the sand is insoluble because it does not. And you can tell it's insoluble because you can see the water and you can see the sand. Conductor and insulator. So conductor means it allows electric current or heat to flow, and insulator means it does not allow current or heat to flow. And the way we test it is we use a conductivity meter, something that you will be using in this class. So let's take a look at the conductivity meter. At the bottom you have these two probes. If a substance is a conductor, it will close the circuit, which then allows the light signal to turn on. And if it's a strong, and the light signal can tell you if it's strong, weak, or a non-conductor. All right, so you're going to watch this video on how to use a conductivity meter, and then when we come back together, we'll finish this video up. All right, the last property we're going to look at is density. That you know from before. Density is how compact a substance is. And the way that we determine it is we measure its mass and volume, and you guys did that in Unit 1, so this is actually a property that you have experienced. Okay, let's move on to why are properties important. So just like with anything, we like to use information to sort of make predictions. And here, let's say, for example, you had two choices of vehicle. Which one would you use in a race? Which one would you use to move a couch? And how did you make that choice? Take a moment to think about your answer. And when we come back together, we'll talk more about it. All right, you probably chose the first one for the race because it's a sleek car, so you know it looks like it will move fast. It's a sports car, so this one will probably win you a race, whereas a pickup truck has a truck bed in the back that has extra room to move the couch. And so we can tell just by looking at the shapes of these things how we would want to use them, and also the vehicle class. Like this is a sports car, this is a pickup truck, so we know from there what its usefulness is. So the idea is, this is why property is important. Different types of matter have different properties. And the properties of matter help us classify that substance, which enables us to make predictions about either how to best use it or study it, and also how to predict the outcomes of that study. So types of matter if they have certain types of properties. We look at a bunch of patterns for properties, and then we use that